In 2026, SpaceX is expected to do what no private space company has ever done at this scale: ask public markets to price a company that already controls the majority of the world's orbital launches. Falcon 9 has flown more missions in a single year than most nations have managed in decades. Starlink has turned satellites into a consumer utility. The Pentagon now treats SpaceX as infrastructure, not a vendor. But the IPO is not just a valuation event. It is the moment investors discover that orbit may have a gatekeeper, and that gatekeeper is Elon Musk's company. By the mid-2020s, SpaceX was not merely launching rockets. It was setting the tempo of space. Falcon 9 flew more often than any orbital rocket in history. In 2023, SpaceX completed 96 orbital launches. In 2024, it passed 130. Boosters landed on drone ships, returned through Port Canaveral, went through inspection, and flew again. Some first stages accumulated 20 or more flights. A vehicle once treated as disposable became an asset worked like aircraft equipment, with its costs spread across repeated missions. Cape Canaveral and Vandenberg turned into industrial corridors, not ceremonial launch sites. The customer list reveals the scale of dependence. NASA uses SpaceX's Dragon to carry astronauts to the International Space Station after the retirement of the Space Shuttle in 2011. The Pentagon buys national security launches through the National Security Space Launch Program and studies resilient satellite networks built around rapid replenishment. Commercial satellite operators buy transporter, rideshare missions, purchasing access to sun-synchronous orbit by the kilogram instead of waiting years for dedicated rockets. Then there is Starlink. By late 2024, more than 6,000 active satellites in low Earth orbit launched largely on SpaceX rockets, filling SpaceX's own manifest. The company became both the carrier and one of its largest customers. That is the structural change. Satellite companies, defense planners, telecom buyers, and governments do not simply compare SpaceX prices. They plan around SpaceX availability. When one company becomes the schedule, every delay, priority, discount, or refusal becomes a form of power. SpaceX was founded by Elon Musk in 2002 with an argument that sounded implausible in an industry built around government contractors. Rockets were too expensive because no one had been forced to make them cheap. The company nearly died proving it. Falcon 1 failed 3 times between 2006 and 2008. A fourth failure would likely have ended SpaceX. On September 28, 2008, the fourth Falcon 1 reached orbit. Weeks later, NASA awarded SpaceX a commercial resupply services contract worth roughly $1.6 billion. That was the opening. NASA's Commercial Orbital Transportation Services program had taken a calculated risk. Instead of owning every piece of the vehicle, the government would pay for capability. SpaceX used that opening to build Falcon 9 and Dragon, then did something incumbents had long dismissed as impractical at scale. It landed orbital-class boosters and reused them. Gwynne Shotwell's role was decisive. Musk supplied the engineering pressure and appetite for risk. Shotwell turned it into contract discipline. NASA cargo, NASA crew, commercial launches, military work, and customer confidence. Reusability was not a spectacle. It was an economic weapon. SpaceX attacked the cost structure that protected ULA, Arianespace, and Russia's Proton-era launch business. Once the booster came back, the industry's old pricing logic began to crack. The SpaceX machine works because each part feeds the next. Reusable Falcon 9 boosters reduce the marginal cost of launch. High cadence gives engineers more flight data, improves operations, and spreads fixed costs across more missions. Reliability improves because the same hardware family flies again and again. Lower prices attract commercial customers. Government contracts provide baseline demand and credibility. Starlink absorbs enormous launch capacity internally, making SpaceX less dependent on outside customers to keep the factory moving. This is the toll road model. External customers pay to reach orbit. NASA pays for crew and cargo access. The Pentagon pays for assured launch and strategic resilience. Starlink pays in effect by filling the manifest, then monetizing satellites through broadband subscriptions, maritime terminals, aviation links, enterprise service, and government contracts. Every additional launch reinforces the advantage. Competitors must prove rockets that fly occasionally. SpaceX proves rockets by flying constantly. Starship is the next lever. If Falcon 9 lowered the price of orbit, Starship is designed to change the volume of orbit. More mass, lower cost per kilogram, and the possibility of deploying satellites, fuel depots, lunar hardware, and eventually larger orbital infrastructure at a scale Falcon 9 cannot match. That is why the IPO matters. Investors are not only buying rocket revenue, they are buying a system where launch, demand, satellites, and government dependence compound inside one balance sheet. The decisive turn was not a rocket, it was a terminal. Starlink began as a way to fund Mars ambitions and monetize low Earth orbit. But once thousands of satellites were deployed, it became something more valuable than a broadband product. A communications layer independent of fiber cuts, local towers, and many national telecom choke points. In rural markets, that meant internet access where cable economics failed. By early 2024, SpaceX said Starlink had more than 2.6 million customers across dozens of countries. At sea, it meant cruise lines, merchant fleets, and offshore operators could buy high-speed connectivity outside legacy satellite pricing. In aviation, carriers including Hawaiian Airlines and Qatar Airways moved to install Starlink on aircraft, challenging the old in-flight connectivity model. In disasters, from hurricanes to wildfires, suitcase-sized terminals restored links when terrestrial networks were damaged. In Ukraine, after Russia's full-scale invasion, Starlink became battlefield infrastructure. Tens of thousands of terminals connected troops, drones, hospitals, and government agencies. That created a new political reality. Decisions by a private company could affect communications in an active war zone. The Pentagon later moved to formalize parts of that dependence through contracts. In September 2023, the US Space Force awarded SpaceX a Starshield services contract valued at up to $70 million, a modest figure by defense standards, but a clear signal of direction. This is where the conflict sharpens. The same network that sells broadband to households can support military resilience, sanctions enforcement, intelligence movement, and command links in contested regions. SpaceX's leverage no longer comes only from launching satellites. It comes from operating them, and from deciding where, when, and under what terms connectivity exists. Once SpaceX became the low-cost route to orbit, the rest of the industry stopped moving on its own clock. NASA depends on SpaceX for crew transport to the International Space Station, and on Starship for central elements of the Artemis lunar architecture. The agency awarded SpaceX the first human landing system contract in 2021, worth $2.9 billion, making Starship part of the planned return to the Moon. That dependence lowers costs and accelerates missions, but it also concentrates operational risk. If SpaceX slips, NASA's calendar slips with it. The Pentagon faces a similar bargain. It wants resilient satellite constellations, rapid launch, and the ability to replace assets in a conflict. SpaceX can provide capacity at a pace few others can match. But military resilience built through one dominant supplier creates a different vulnerability: strategic dependence on a private infrastructure owner. Commercial satellite operators face the cleanest contradiction. Many need SpaceX to launch, while also competing against Starlink for connectivity markets. The supplier is also a rival. The responses are specific. United Launch Alliance flew Vulcan for the first time in January 2024, replacing Atlas V and Delta IV while trying to preserve a national security alternative. Blue Origin, backed by Jeff Bezos, pushed New Glenn toward orbit after years of delay, with Amazon's Project Kuiper waiting for launch capacity. Arianespace flew Ariane 6 for the first time in July 2024, after Ariane 5's retirement exposed Europe's gap in autonomous access to space. China's state-backed launch ecosystem accelerates for a different reason. It cannot allow strategic access to orbit to depend on an American company, and it has been sustaining more than 60 orbital launch attempts a year. Launch has stopped being a neutral service market. It is a control point. The 2026 valuation is not just a price on Falcon 9, Starship, or Starlink subscribers. It is a price on leverage. Investors are buying exposure to the company that may control the highest cadence launch system, the largest low Earth orbit communications network, a major channel for military resilience, and a possible infrastructure layer for the next phase of data and compute. That last piece is early, but the incentives are clear. AI systems need connectivity, data movement, power, and eventually new physical locations for compute. Satellites already relay information across oceans, aircraft, ships, battlefields, and remote industrial sites. Larger launch capacity could make orbital data centers, space-based power experiments, and high-volume relay infrastructure less theoretical over time. If those markets emerge, the company that lowered the cost of placing mass in orbit begins with a structural advantage. Public markets may bring more transparency, revenue, margins, debt, capex, contracts, and concentration risk. But transparency is not the same as competition. The unresolved question is no longer whether SpaceX can reach orbit. It has answered that hundreds of times. The question is, what happens when access to orbit, communications from orbit, and the first layer of industrial infrastructure beyond Earth are increasingly routed through one private gate: aircraft, battlefields, markets, and machines. If that layer moves off Earth, the company that owns the ride, the network, and the operating rhythm gains something more durable than a launch contract. It gains position. The IPO will put a public price on that position. But the deeper question is not what SpaceX is worth in 2026. It is what the world becomes when access to orbit gets cheaper, faster, and increasingly dependent on one gatekeeper.